Welcome to Imaginary Numbers lesson by Sidnie Jones. Woo! Okay, so first of all, imaginary numbers were invented because negative numbers do not have a negative numbers do not have square roots. So there you go, imaginary numbers. Okay, so the formula for imaginary numbers are not AX. My bad, I don't know where I got that from. A plus BI. A is the real number. BI is the non-real. This right here is very critical for you to know. So I would memorize this. And I'm not going to say it out because we can all read. But this one right here is hard to understand because this one is I squared equals -1. I'm sorry, people. I had a mishap on that. Okay, so anyway, the rules for I is, number 1, no answer may have an I to a power greater than 1. Example. So if the exponent here is greater than 1, then you need to simplify it using this table here. Okay, so no I can be in the denominator. So if there's a denominator, if there's an I in the denominator, then you need to do this or use the complex conjugate. The complex conjugate, you would take the A plus BI and then do the reciprocal of that, which would be A minus BI. Okay, so then once you multiply that, you would get the number and then I, and then that'd be over -1, which would change that right there. So that'd be negative, and then the number, and then I. Okay, so for adding and subtracting, for this right here, for these examples, it would just be regular adding and subtracting. And it's going to get more complex as we go, but this is the basic. What you would do, like for the basic, like 10i minus 6i and 4i and And then for this one, you would just be regular multiplication, how to do that, and it will get more complex as we go. And dividing here, you would just divide regularly, and yes, we all have been through kindergarten, Sidnie. Let's move on. Okay, so I'm just going to do one more wipe through. You pause it as you need to go. Snap, crackle, pop. Okay, and now let's move on. Examples of what we have learned today. Okay, so you're going to need to pause this as you go, so then you could do it by yourself, and then I'll go over it with you when you unpause it. Okay. Okay, simplify as much as possible. Okay. I'm just going to. Okay, there we go. Okay, for this one, you would have to branch this out, and this would be -1. The square root of -1 times the square root of 25, and we all know that equals 5. And this is equivalent here because when yes, we all know, Sidnie. Okay, so then you would get 5i. When you multiply I times 5, you get 5i. And over here is a little bit more complex. Okay, so then you have -2 outside the radical. Okay, so then you have the 2 would go over Okay, so once you branch out from the 9, it would get the square root of -1, and then you would have 9. The square root of 9, we all know that equals 3. And then the 2 would go over here with the I because, you had to convert that, simplify it down. And then you would multiply those together and you get 6i. Okay, let's move on. Oh, snap, crackle, pop. Okay. You didn't see that? Adding and subtracting with imaginary numbers. Okay, so then you would get 2 to the square root of -28 plus the square root of 63. And then you know how to do that one. Okay, so pause and play. Okay, here. Okay, so we're doing it one hand here. Okay, here we go. It's coming down. There we go. Okay, so right here, what you would do, it would be right here because you have to split the 28, and then you would get that, and this was the square root of -1, which should go with the 2 So 2i square root of 28, and you split that up because there's no exact square root of 28, and then you get 4 and then 7. And then this right here, okay, so this would be 2i times 2 because you have to multiply the 2 times what you get out of here, so then that equals 4i. And then you have 7, you bring the 7 down here, and then over here you split up the 63 from 9 and 7. From the house, it has to split up, okay? Not split up, it has to like have a square to it. So that would equal 3, and you get 3i, and then you get 7 right here, and then you get, when you add them together, add the like terms together, you get 7i to the square root of 7, and over here you would just add over here. So then 3, you would add the like terms together. So then 3 plus 1 equals 4, and then you have 2i plus 7i equals 9i. And then down here, dividing with imaginary numbers. Express each with a real denominator in the simplest a plus bi form. Okay, so then down here, remember this one, okay, pause. Okay, play. Okay, so this one right here you would have to, here, I'm just going to go down. Down there. Okay. So then this, okay, so this right here, so you would have to multiply like how we did the beginning of the video. You would have to do I over I, and then you would get 2i, and then this would be -1. So then you would get 2i. Okay? So down here. Okay, so then you would have to do the complex conjugate of this because you don't want the I in the denominator. So then you would have to FOIL that out, and you would get 8 plus 10i plus 12i plus 15i squared. And then down here, this changed because we have to simplify this, because any exponent to the greater than 1 has to be simplified. Okay, and then you would get 8 plus 10i plus 2i minus 15 over 16 plus 20i plus negative 20i. I meant that be a negative 20i plus 25. Okay, so down here the 20i left because it canceled each other out, and then you would get -7 plus 22i over 41. Okay, and we flip it, and I didn't close your eyes, people. Okay, simplify each of the exponents less than 4. Okay, we didn't go over this in the video. I didn't write this down because I was going to explain it now. Okay, so right here. Okay, you can try it if you want, but if you don't understand it, that's fine. Okay, so that. Okay, so then you have 3i to the 13th plus 4i to the 55, to the power of 55. So then you would have to divide it by 4 because that's the highest exponent. And then what you get down here, the remainder, would be the exponent. So then when you divide 55 into 4 into 55, you get 13 with a remainder of 3. So then your exponent would go right here. And once you simplify that down, because it can't be greater than 1, you get 3i minus 4i equals -i. And when you go over here, boop, 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 this would be 4 goes into 7 once. So then you get 3, and then that would be over here. And why isn't that right, people? Because we have to simplify it. So then you would get -i. This is wrong. This is the correct answer. Thank you for helping me. I hope you enjoyed this video.